As you remember, Shabab, the two sections 4.1 and 4.2 are about exponential functions, what they are and how they looks like. What is the graph of these functions? So this is the standard form of the exponential functions. Of course, a greater than 0, a is not 1. And the graphs the graph of these functions. It takes this shape and all of them passing through the point 0 and 1. When x, you can see clearly here, this is for a greater than 1. This is for a between 0 and 1. This is for y equals a to the power x. This is for y equals a to the power negative x with a greater than 1. Okay? So this is the same. This is the same of a to the power negative x with a greater than 1. These are the same. You can see here clearly that what happens when x goes to negative infinity, y approaches 0. So this means that the x-axis is a horizontal asymptote. When x goes to infinity, y approaches 0. So also here, it is clear that the x-axis is a horizontal asymptote. The range, the domain and the range, we have mentioned this yesterday. What is common between the graphs of a to the power x? All of them passes through the point 1 and a, because a to the power 0 is a to the power 1 is a. All of them passing through the point 0 and 1, all of them passing through the point negative 1 and 1 over a. Here, what we have f of, they can give you this question as a graph or as follow, like this. Here, what is f at 2? 25. So you may have this graph like this, or without this graph, this is enough. If you have this function like this, what is the function? What is this function? What is a? How to do that, Yashaba? Clearly here that f at 2, it is 25. What does that mean? This means that a to the power 2, this is a to the power x, x is 2. So a to the power 2 is 25. And you know that 25 is what? 5 to the power 2. So what is a? Clearly a is what? A is 5. Someone of you will say, we will take the square root. Why a does not equals to positive or negative 5, Shabab? Why a is not positive or negative 5?
Because here it said don't take minus.
A is always greater than 0, and a does not equals also 1. Be careful. Wherever we have exponential function, a always is greater than 0. So this is why we don't take the negative values. Similarly here, ya Shabab, we have here f of x equals to a to the power x. What is f at 3? We have a point here. F at 3, it is 1 over 8. So this means that a to the power 3, it is 1 over 8. What is 1 over 8? It is 1 over 2 to the power 3, which is a to the power 3 equals to 2 to the power negative 3. Okay? So this means what? Or you can write it in a better way. This is a half to the power third. This is 1 over 2 to the power 3. It is a half to the power third. So we have here, if you take the cubic root of both sides, you will have a to the power half. Here there is no positive or negative. It is only one case. So a is a half. Okay? So these type of questions, ya Shabab, they might be given for you in terms of graphs or in terms of these details about the functions. In both cases, you should be able to find what is this function. We will take an exercise about that. But before that, ya Shabab, again and again and again, you need to revise the graphing techniques that has been studied in 2.6 about shifting up and down, reflecting, and so on. Let's see how to sketch the graph of this function, 2 to the power x plus 1. It will be the same as the graph of 2 to the power x shifted 1 unit up or down.
1 unit up.
1 unit up. So this is the graph. All of these functions, Shabab, will pass through the point 0 and 1. So all of them are like this. Just it is a matter, it is like this or like this? It is narrower or wider. So the blue graph is for y equals 2 to the power x. Here it is. It passed through the point 1, 0, and 1. Now what we will do, we will shift it up. How to shift it up, ya shabab? We will focus on this point. We will focus on this point. It is 1, so it becomes 2 because we are moving up. Okay. So this will be the y-intercept. Also, what is the horizontal asymptote here? The horizontal asymptote here is y equals to 0, the x-axis. So it will be also shifted up. So it will be y equals what? 1. So now this is the horizontal asymptote. So be careful when you sketch the graph of any exponential function, you must also sketch the horizontal asymptote. Okay, if there is. Good. Now, what is the change, ya shabab? What is the domain? Because we need to find what is the domain, what is the range, what is the asymptote. So for this function, it can be clearly seen that the domain is still all the real numbers. There is no change on the domain. Any vertical shift will not change the domain. Okay. For the range, there is a change in the range. Previously, for the blue one, for 2 to the power x, the range is from 0 to infinity. Now it is from where to where, Shabab? From 1 to infinity. Is that right? So it looks like just this one will be added. So instead of starting from 0, we will start from 1. So keep this in mind, Shabab. When we have 2 to the power x plus 1, the range will be, the range of this function will be from 1 open to infinity. And also the horizontal asymptote is what? Y equals to 1, not y equals to 0. Excellent. Let's take now the second function, negative 2 to the power x. What is this? This is the same as 2 to the power x, but it will be shifted or reflected or what? When we have y equals f of x, what will happen if we multiply the whole function by negative?
Reflected around the y-axis.
The x-axis or the y-axis? You have to be sure. You should remember the graphic techniques. When you multiply the function, the whole function by negative, it will be reflected in the x-axis. If we replace x by negative x, it will be reflected in the y-axis. So let me confirm that again. If we have 2 to the power x, this is the graph of 2 to the power x. If we change it to be 2 to the power negative x, it will be reflected on the y-axis. It will be like this. But if we put it 2 to the power x, but negative all of them, it will be reflected like this on the x-axis. So for this function, we have the following. This is 2 to the power x. Now it will be reflected in the y-axis. It is easy, ya shabab. When x is 0, when x is 0 here, when x is 0, you will have 2 to the power 0, which is 1. Here it is. But when when it is 0, it will be 2 to the power 0, which is 1. It will be negative 1. So it will, this point will be here. Instead of being 0 and 1, it will be 0 and negative 1. Now, the horizontal asymptote, we still have when x goes to negative infinity, y goes to 0. So the horizontal asymptote, it is still the x-axis. So you will just make a mirror here, like a mirror. You have a mirror here, and just draw this one and flip it down in the same way of reflection. Great. What happens for the domain and the range? I forgot to mention that. Now we still have the horizontal asymptote is y equals to 0, the same. Now what happens to the domain? Also the domain, Shabab, is still the same, from negative infinity to infinity. Where is that change here? The change is in what?
The range.
In the range, ya Abdurrahman, ya Mansoor. Yes, ya Shabab, I wanted to be all of you to be active, not only Mansoor and Abdurrahman and a few students. So the range here is what? The range for this one, it was from 0 to infinity. Now, for this one, it is what?
Minus infinity to 0.
From negative infinity to 0. Okay? Great. The horizontal asymptote is still the same, of course. Let's take the third one. What we have here? We have here 2 to the power x minus 1. So this is indeed the same as 2 to the power x, but shifted 1 unit to the
Right.
Right.
You are right. You are right. To the right. Also, there is another way, by the way. You can consider it like this: a half 2 to the power x. So it looks like shrinking. So it looks like you multiply this by a half. So it will be vertically shrunk. Okay. So you can look at it in two different ways. But let's look at it just as a horizontal shift to the right. Okay. So this will be shifted 1 unit to the right. Now, what you need to do, you need to start with this. Sketch the graph of 2 to the power x. This is 2 to the power x. Now, this point, it is 0 and 1. So it will be now at 1 and 0. Both x equals to 0 here. What you will have? You will have a half. So this point will be shrunk. This is why we will have vertical shrinking. So at 0, it will be a half. Here it is. At 1, it will be 1. At 1, it will be 1. So this point now here it is. So this is why we have that. But we still have a shabab, when x goes to negative infinity, y goes to 0. Check that. And because of that, we still have the same horizontal asymptote. The horizontal asymptote, ya shabab, will not be changed unless we have a vertical shift. If there is a vertical shift, it will be changed. Otherwise, it will stay the same. You can see clearly that the domain is the same. The range is still the same. So, and also everything is the same as 2 to the power x. Any question, Shabab, because we summarize, this is the summary of all what we did before. In general, Shabab, if you have a to the power x plus b, b is positive or negative. It could be x minus 3, x plus 3, for example. Whatever, b is positive number or negative number. Plus c also, it could be vertical shift or horizontal shift. Vertical shift up or down. Now, if you have a function like this, what will be the domain? The domain will be all the real numbers. The range will be from c to infinity, like what we have here before. If you remember, when we have 2 to the power x plus 1, it was starting from 1. So now the range will be from c to infinity, and the horizontal asymptote will be y equals to c. This will summarize everything. So if I ask you this question, for example, y, let me ask you this, y equals to 3 to the power x minus 1 plus 2. You can now find what is the domain, and what is the range, and what is the horizontal asymptote. The domain is all the real numbers. And of course, the range is what? The range is from c to infinity, and c in this case is 2. And the horizontal asymptote is y equals to 2. So easy. What about if we have negative here? When we have reflection, like here, when we have this function, y equals to negative 3 to the power x minus 1 plus 2, for example. Let's say like that. So what will be the change? The horizontal asymptote will stay the same, but here the range will be what, ya shabab? From negative infinity to c. So it will be, the range of this function will be from negative infinity to 2. Okay? Excellent. Now we are done with 4.1. We will take another exercise, inshallah, at the end. Let's now go to 4.2. Again, 4.2, ya shabab, it is just about the natural exponential function. Just when we have a equals to e. What is the difference? We will see that now in a minute. We will see also how to sketch the graph of this function. What is the number e, ya shabab? The number e is an irrational number. It is irrational number. Indeed, it is this number: 2.7, 18, 28, 18, 28, 45, 90, and so on. It depends on your computer how many digits you can show. It is irrational number. It is like pi. So we can just to make it easy to remember it, shabab, it is approximately you can say 2.7. Okay, this is approximately, not exactly. From where it comes, indeed, it is one of the most famous numbers, shabab. It has a name, by the way, e. It is called Ailer number. It is named after the mathematician Ailer. It comes from as a limit for this. So e, it is the limit of 1 plus 1 over n all to the power n when n goes to infinity. So it is, look here, 1 plus 1 over n all to the power n. When n goes to infinity, when n is getting larger and larger, bigger and bigger, this value, it is getting closer and closer from 2.711828. Okay. Now, in fact, if you are interested about from where it comes and what is the number E, I put here some links for you. You will enjoy them. I'm sure about that. Just let me mention that the most important applications, they are almost everywhere now. You can see the exponential function everywhere. But one of the most important application of this is the compound interest, ya shabab, in the banks, when they use it in the finance and banks. حساب الفائدة المركبة بيستخدموا فورمولا زي هاي قريبة من هاي B plus C over N all to the power N, something like that, and they call it the compound, the interest compound. So I will leave this for you, Shabab, because we don't have much time. This function, the exponential function, it is one of the most well-known functions in calculus, and it is the only function in the world that is its derivative the same as its function, the same as it is. Also, its integral. So its integral is the same. Its derivative, it is the same. You will like it the most in Math 101 and Math 102. Now, this is the function, Shabab. This is just when we replace A by E. E, indeed, it is 2.71828, blah, 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 blah. So shortly, we will not write that. We will just call it E, like pi. We don't write by exactly what is it, 31.44. So they call it, of course, natural because it comes from nature, and we didn't invent that number. This is one of the magic numbers that appears in the nature. It is like pi. We didn't invent it. We just discovered it, okay? How it looks like, what do you expect the graph will be? Because E, it is almost 2.7, so it is between 2 and 3, and it is closer to 3. So its graph, if this is the graph of 2 to the power x, and this is the graph of 3 to the power x, E to the power x, it is natural to be in between them. So it is more close to the graph of 3 to the power x. Also, it will pass through the point 0 and 1. E to the power 0 is 1. Also, we have x-axis as a horizontal asymptote. Here, ya shabab, we have the 3 or the 4 cases for the graph of e to the power x, like any other exponential function. This is when we replace x by negative x, we have a reflection in the y-axis. When we replace e to the power x, when we multiply the whole function by negative, it will be, instead of above the y-axis, it will be below the x-axis. Here it is, when it is negative e to the power x. Also, when you reflect this one, this graph, when you multiply it by negative, here it is, it will be like this. So be careful, Shabab. You should be able to sketch the graph of e to the power x, e to the power negative x, negative e to the power negative x. Let's start with x, and then negative e to the power negative x. These are the 4 cases, okay? The summary is here for you. And this is the summary of this 2 sections, 4.1 and 4.2. Okay, I want you to pay special attention to this. And don't forget that this graph also here, this one, is the same as a to the power negative x when a is greater than 1. Okay, any question, Shabab? Is that clear? Let's take an exercise about that. We have, inshallah, time. I'll skip this, ya Shabab. I will keep it for you because it is completely solved here. If there is anything that is not clear for you, you can see me during the office hours. طبعا يا شباب, for the office hours today, it will stay the same. It will stay from 10:40 to 11:40. If there is any change, it will start, inshallah, from tomorrow or from next week. Okay, let's look at this exercise. Yalla, shabab. Turn your brain on. If the graph of this function is given below, so the graph is here. What is A, B, and C? What is 2A plus B plus C? Okay, so now what is the easier thing to find? Now you need to lock here, and lock here. So from here, ya shabab, from here, what is the horizontal asymptote?
Y equal 1.
From here, y equals what?
1.
From here, from the function, not from the graph.
C.
Y equals C. Is that right?
Yes.
So from here now, what is the horizontal asymptote from here?
A 1.
Like
One.
what? So what
Minus
we
one.
conclude from why
Minus one.
we conclude that C is 1. So easy. So this is the first thing that you should have when you have a exponential function. What is the horizontal asymptote? Good. Now we did find C. Now let's update our function. Now our function, it is negative a to the power x plus c plus 1. If it was negative 1, we will write minus 1. So this is plus 1. Good. Now we need to find b. It is not easy to find a at the beginning. You need to find b. How to find b?
Sir,
Yes.
we shift two units to the right from -1, so b equals 2.
How you are sure about that?
But
Do you
minus.
know that a is greater than 1 or less than 1? The graph will be different. Be careful, ya shabab. I don't want you to take the risk and start thinking about shifting, because you know if a is greater than 1, the graph will be like this. If it is less than 1, the graph will be like this. So be careful. And we have here reflection. What I advise you, ya shabab, to do, ya Muhammad Sultan, what I advise, you can do whatever you want. Okay, it's okay. There is many methods, but let me give you in the short time what is the best way. What is the best method? The best method, ya shabab, to use the points that they are given for you. Look here what we have. We have a point here, and we have a point here, and we have a point here. Why they give me these points? I should use them. Okay, so this point, ya shabab, here, what does it tells me? It tells me that f at 3 equals to what? 0. So I will put x equals to 0. I will use this point, which is 3 and 0. I will use it here. Both x equals to 3 and both y equals to 0. Now you will move this to the another side, or move this one to the another side. So what we have here? What we have here is a to the power something, a to the power something equals to 1. A to the power what, ya shabab, equals to 1?
0.
A to the power 0. So this means that this is 0. So this means that this is 0. And this is so easy equation. So b is -3. So now we know that it is -3. You can think about shifting, but be careful. There are many tricks. I can tell you that it is not the same, because a here, we don't know a if it is positive or negative, or sorry, if it is greater than 1 or less than 1. But it is, for this specific example, it works, because it should be clear that a here is less than 1, as we will see. Now we use this point. Done. Let's use this point now, or this point, any one of them. It is up to you. So let's choose the smaller one. 2. What is this point, ya shabab? This point, it is what? 2 and -1. So let's use it. 2 and -1. So both x, now update your function. Your function is what now? -a to the power x. What is b? B is -3. So this will be -3 plus 1. So what we are left up with? We left up with a. Okay. So to find a, what you need to do? Again, use this point or that point. So we use 2 and -1. So it will be 2 minus 3. And of course, this will be to the power -1. Move it to here, it will be -2. So now multiply by -1, it will be positive. 2 equals to positive a to the power -1. You know that a to the power -1, it means 1 over a. 1 over a equals to 2, means that a to a equals to 1, a equals to a half. So a is a half. Okay. Now you can, of course, continue finding the value of that one. Again, it is risky, ya shabab, to use the idea of shifting. Try to solve the old exams. There are many old exams, ya shabab. Did you, ya shabab, take the recitation class today, or it is after this class?
It's
Okay, this type of questions, ya shabab, you will take it in the recitation class. This type, if you still have, if it is not clear for you, you can discuss it with me. So I will skip this because everything is here. And there are, I think, 1 or 2 questions in the recitation about the same idea. So I will skip this. How to sketch the graph of this function? It is very important to know how to sketch the graph with absolute value. Okay, you know, shabab, in general, when you want to sketch the graph of a function, what you should do, you should start with this one. You should start to sketch this one. For example, it was like this. Okay, let's say like this. Now the graph of y to the power, the absolute value of f of x will be what? Will be like this. It will be the same, but just you will shift it up like this. Yes.
Any part below the x-axis will be reflected around the x-axis. That's the only difference.
Exactly. Yes, you are right. Totally right. Thank you. Who's that?
It's me, Muhammad Sultan.
Thank you, Muhammad. You are right. Totally right. Thank you. So now let's see, ya Shabab, start sketching the graph of this function. So what we will start with, ya Shabab, we will start with the basic function. You know how to sketch e to the power x. Here it is. Sketch the graph of e to the power negative x. Here it is. It will be reflected in the x-axis. This is e to the power x. Then negative e to the power negative x, which will be, of course, reflected in the y-axis. It should be like this. Revise, ya Shabab, the slides that I give you, the 4 cases. So this is the graph of this part. Okay. Now shifted up 4 units. We shifted up 4 units. Now the horizontal asymptote is here. It is at 4. Now what you will do at the end, what is below the x-axis, you will make it above the x-axis. So this part is below the x-axis, reflected because of the absolute value. So just it will be reflected. So this point will be here, and this point will be here, here, and it will be like this. So here we are. This is how it looks like. Now, what is the question? The question is the graph of this function is decreasing. Where it is decreasing? From where to where? Look at this. It is decreasing from here, from negative infinity to this point. We don't know what is this point. This is the x-intercept of the graph. But if you look at the choices, ya Shabab, from negative infinity to this, from negative infinity to infinity, from negative infinity to the power, it is clear what is the right answer. Is this positive, ya Shabab, that we don't know? This number positive or negative?
Negative.
So it is this choice. This is the right answer. Because this number is positive. Len 2 is positive, by the way. Len, this is negative. So no need indeed to find what is it. But if you want to find it, it is not difficult. You know, ya Shabab, how to find the x-intercept. To find the x-intercept, this number, by the way, it's negative len 2. How to find it? For len, this len, we will take it in the next section in 4.3, inshallah. The x-intercept, you need to find the x-intercept. So you will put this equals to 0. Then you will solve it for x. So e to the power x, it means that x is len 4, negative len 4, and len 4 is 2 to the power len 2 to the power 2, which is 2 len 2. We will take this, don't worry about this, but we will take it in 4.3. Great, ya Shabab. I will give you 2 minutes to solve this. This is the last exercise that I want you to have. Which one of the following statements is true about this function? Yalla, ya Shabab. Think about it. Which one of the following statement is true about this function? Who can give us a hint, ya Shabab? There is something that we need to do at the beginning to make it easier. What is it?
2 to the power minus 1.
بدل ما يكون عندنا half يا شباب نخليها 2 to the power negative 1 ولا لا؟ ايش رايكم؟ عشان بعدين نضرب النيجاتيف 1 by 1 minus x. فالفانكشن راح تكون 2 to the power x. هذا راح يصير بوزيتيف وال1 راح يصير نيجاتيف minus 1. This is easier يا شباب. Now it is much easier. Now my question is, we have here like 4 questions, not 5 questions, not 1 question. So what do you think? Do we need to sketch the graph? طبعا before you can sketch the graph, it is not difficult يا شباب. It is shifted down 1 unit and shifted to the right. But I advise you. Yes, ya Abdullah, yes.
I think B.
The answer is B. You are right. You are right. We will see why, ya shabab. So if you have a question like this, ya shabab, you can go and sketch the graph. It's okay. But I advise you to check the answers that you can know without a graph. So if you are sure about the answer, you don't need to sketch the graph. Yes, Amigdad.
Yes, doctor. Just I will explain this question. The first part, half power 1 minus x, that cannot be 0. And if it will be
Amigdad.
0, but it cannot
It's
be.
okay. It's okay, Amigdad. Thank you, Amigdad. We don't have that time indeed. Just let me mention one idea here that I'd like to focus on similar questions, not specifically this question. If you have a question like this, Shabab, thank you, Amigdad. If you have a question like this, go to the choices. If you can check some of them without graph, this is okay. So try to avoid sketching the graph as much as possible. So for example, the x-intercept is -1. No need to sketch the graph here. What is the x-intercept? You will put y equals to 0. So you will put this equals to 0. So you will try to solve this equation. We will see that in 4.5. Okay? So easy. So you will find that it is not -1. بدليل انه لو حطيت بدل الاكس -1 ما راح يجيك 0. Okay? So this is not a good choice. Now the range is from -1 to infinity. This is clear, ya shabab. I told you when you have a to the power x plus b plus c, this means that the range is from c to infinity. Okay? If there is no reflection here. So here it is. C is -1. So this is the right choice without sketching the graph. But here, for example, if you want to see that it is decreasing, you need to sketch the graph. But of course, this is increasing because it is 2 to the power. And the domain is clear. The domain, of course, is all the real numbers. This is wrong. This is wrong. And the y-intercept is -1. So you will when you put x equals to 0, you will not get -1. So this is wrong. So no need to sketch the graph, ya shabab, here. Okay? No need to sketch the graph unless you are suspicious about this, if it is the right answer or not. Thank you, Mansour. Thank you, Muhammad, and Abdullah also as well. I think we will stop here, Shabab. If you still have any questions about 4.1 and 2, you can contact me during the office hours or by any contact method you want. Let's say goodbye for this section and start section 4.3 in the remaining 15 minutes. And also, this is an interesting section, and also it is a short section. I wish we will, if we didn't finish it today, we will finish it tomorrow, inshallah. Okay, this section, Shabab, is about logarithmic functions. What they are, we will see together. How to sketch their graphs, how they look like, and what is the common and the natural logarithms, okay? So now, Shabab, before starting about the logarithms, let's go back to 4.1 and 2 and mention the exponential. This is the exponential function, Shabab. You can see clearly that the exponential functions are what? 1 to 1, Shabab, because it is either increasing or decreasing. Even a to the power -x, it will be like this. So it is decreasing. So it is all of them, if you draw by the horizontal line test, they are 1 to 1. Is that clear? So because they are 1 to 1, they have an inverse. So the exponential function has an inverse. What is the inverse? So now when we say y equals 2 to the power x, for example, what is the inverse of this function? What we have here, for example, if x is 3, what is y? Y is 8, is that right? The inverse will do what? Will do the opposite. So here, let me call it f of x. Here, f of 3 is 8. Now we need a function that is the inverse, such that f of 8, f inverse at 8 equals what, ya shabab? 3.
Can you hear me? The recording router. We can see the photo.
You cannot?
We can see.
Really? I didn't share it.
For the sharing, yeah.
Oh, okay. Thank you for letting me know about that. Well, I'm talking to myself. So why you didn't mention that from the beginning? So
I
let me
tried
go
to
back
get
to
it.
the first slide. Let me go back. Now, again, يا شباب, in this section, we will see together what is the logarithmic function, what are the logarithmic functions, how they look like, what is their graphs, and what we mean by common and natural logarithms. Now, as I said, يا شباب, you know that the exponential function, this is how it looks like. It is one-to-one. Because it is one-to-one, it has an inverse. The question is, what is its inverse? To understand what is its inverse, let's think about this exponential function, this specific one, for example, 2 to the power x. Now, if x is 3, what is y? Y is 8. So we have the point 3 and 8 on the graph of this function. Now, the inverse, if this is f of x, the question is, what is f inverse of x? Because it has an inverse. The question is, what does this function do? Here we have f at 3 equals to 8. This is equivalent to what? F inverse of 8 equals to what? Equals to 3. This is the meaning of the inverse. So now we need to find a function that gives me 3 back. So here we said 2 to the power 3 equals what? Equals what? 8. The question now will be what? 2 to the power what? 2 to the power what equals 8. So we will look for the exponent, not for the result. Okay? This is what we are going to do. This inverse, ya shabab, because it is so important and heavily used in mathematics, they give it a name, and it is coming from Greek, by the way. It means logarithmic. You know, arithmetic, it means hisab, and logos, it means ratio in the Greek. Then after that, in the Latin language, they use this logarithmic. Okay, so the logarithmic function, what is it, ya shabab? If someone asks you about it, it is the inverse function of the exponential function. Okay, and to make it to give it special notation, ya shabab, they just take the first 3 letters to make it log. We can read it log or logarithm. It is up to you. And of course, because we have different bases, the base here is a to the power. We add the base here at subscript here. We call it log a. So this is the inverse of this function. If you have this function, its inverse is this. This is the inverse of this function. Okay. I wish that this is clear, Shabab. So let's read the formal definition now. So if a is a positive, we still have, ya shabab, a greater than 0 and a is not 1. Then the logarithmic function with base a, which is denoted by this logarithm with base a, is defined like this. Log a of x equals y if and only if a to the power y equals x. And this is similar, ya shabab, to saying what? Y equals f of x if and only if x equals f inverse. Let me write it in the same order. X equals f inverse of y. This is the same, of course, of the definition of the inverse. So what I want you to focus on, ya shabab, is this. Please pay attention. What is the relationship between the exponential and the logarithm? Log a of x equals y means that a to the power y equals x. So easy. So log a of x is the exponent. So what is this? This is the exponent, ya shabab. This is the power. Log y is the log, to which is the base must be raised. How to read it? We read it, ya shabab, like this. Log base a of x is y. Log base a of x is y. Now here, for example, this is the base, this is the exponent. And if you write it in the logarithmic form, this is the logarithmic form, this is the exponential form. A to the power y equals to x. A to the power y equals to x. It is equivalent. These two forms are equivalent. You can use this or that. Let's apply it, ya shabab. Log 2 of 8 is 3. This is the logarithmic form. What is the exponential form? What does this means? This means what? Who can tell me? This means what?
2 to the
Two-
power 3 equals 3, 8.
2 to the power 3, 2 to the power 3 equals to 8. Great. What does this means? This means what?
10 to the power
Eh,
5.
10 to the power 5 equals to 100,000. Great. What does this mean? The third one, 2 to the power negative 3 is 8. 1 over 8. It is 8. What does this mean? 5 to the power r equals to s. Did you get the idea, Shabab? So you can also, if you have this, you have this. Let's take, I think, one more. So it is important, ya Shabab, to understand that log a of x, it is an exponent. Let me ask Jasir, ya Jasir Al-Ruwaili, what is this equals to, ya Jasir? Are you here, ya Jasir, or you are absent? Jasir is not responding, so he is absent. Okay, let me ask Migdad, ya Migdad, yalla. What is log 10 of 1000?
3.
Why?
Because 10 power 3 is 1000.
Excellent, you are totally right. Here it is. Now let me ask Ali Saif, ya Ali. Are you here, ya Ali?
Yes, I'm here. You
Yes,
hear
ya Ali. Log 2 of 32 equals what?
5,
Why?
because 2 square 5 equal 32.
2 to the power 5.
To the
2
power 5 square 32.
You are right, ya Ali. You are right. Abdurrahman al-Marwani, what is log 10 of 0.1? Abdurrahman al-Marwani,
Yes, doctor, I'm here.
what is log 10 of 0.1? If you know, if you don't know, it's okay.
No, I didn't. I know. It's -1.
Why? Because 10 to the
Because-
power negative 1 is, you are right. Excellent, Abdurrahman. Mansour al-Abdullah, what is log 16 of 4, ya Mansour?
16 to the 16 to the power
You will ask yourself 16 to the power what equals to 4?
to the power half.
A half. Yes, you're right. Thank you. Yes. Thank you, guys. Let's go now to the second most important property that you have. If you remember the inverse function property from 2.8, from section 2.8. This is why we spend a lot of time on this section. So now this property here, because we have f of x is a to the power x, f inverse of x is log. Also similarly, if f of x is log a of x, its inverse is a to the power x. So they are inverses of each other. So we expect, ya Shabab, this property also to be valid. So now, if I put this here, or here, another way, we should have this property. So what will be now log a? Let's start with this part. Instead of x, I will put a to the power x, which is this. So here, what we have here, we have this now. We have f inverse. This is f inverse of f. So it will be log a of a to the power x. They will cancel each other and we will have x. So this is why we have log a of a to the power x. This a will be cancelled with this log a and we will have x. Make sure that you have the same base. This is a, this is a. Similarly, Shabab, f of f inverse. So when you have a to the power x and you replace x by log a of x, again, this will be cancelled and you'll have this x. But be careful. This x is not the same as this x. This x is in the domain of the exponential, which is all the real numbers. But this x, it is in the domain of the logarithmic function. And you know what is the domain of the logarithmic function? It is the range. Let's remember this. This one, its domain, it was all the real numbers. And its range, it was from 0 to infinity. Now, for the logarithmic function, it will be the opposite. Now, this will be the domain, and this one will be the range. Okay? because you know that the domain of the inverse is the range of the other function. So what we conclude from here that the exponential and the logarithmic functions are inverses of each other. And these are the properties of logarithms. Now we are starting, ya shabab, focusing on the main ideas here. Log a of 1 equals to 0. Why? Because a to the power 0 equals 1. Log a of a is 1. Why? Because a to the power 1 is a. This is clear. Log a of a to the power x is x, and this will be cancelled, and we have it. Let me ask Hussein Al-Awami. Ya Hussein, log 5 of 1. What is log 5 of 1, ya Hussein? Hussein, are you here? Hussein is here or absent?
Yes, doctor, I'm here.
Log 5 of 1 is what? You need to ask yourself, ya Hussein, 5 to the power what equals 1?
0.
Yes, you're right. This is property number 1, ya shabab. We are using this property for any base. Log a for any base of 1 is 0, but of course a here is greater than 0 and not equals to 1. Be careful. Excellent, Hussein. Thank you. Now let me ask Abdullah Salama. Ya Abdullah, what is log 5 of 5? Abdullah, are you here?
Yes,
I
I'm here.
cannot hear you.
Yes,
What is
yes,
log
I'm here.
5 of 5? Yes. Quickly, please.
I think
Look here, ya Abdullah.
0.
No, it is not 0. What is log a of a?
Five.
It is 1, ya Abdullah. Log a. 5 to the power what? 5 to the power what equals to 5? It is 1.
1.
It is 1, ya Abdullah. Be careful. Okay, here, ya shabab, we have log 5 of 5. So this will be cancelled with this, and we will have 8. Here we have also this will be cancelled, and we will have 12. That's it for today. And thank you, guys, and see you tomorrow. Please, if you didn't send your selfie, send it again. Selfie, ya shabab.